Hello everyone, I am Vedant Vasan Shinde. I am currently in third year of my AIDS engineering from Pune University. In this video, I will be explaining my GenAI project, which is an SPPU exam assistant. So in this project, I have built an AI exam assistant for students, which will help them to study from their textbooks. So the system takes a PDF as the input. The PDF can be a textbook, notes, or any study material which is in text-based format. So the system converts the PDF into embeddings, stores that embeddings into a vector database. Then when a user asks a question, uh, the system retrieves the most relevant part from the PDF. It does not read the entire PDF. It only retrieves the most relevant parts from the PDF, and then it generates a point-wise answer and then give it to the student as output. It can also generate MCQs from the same content. So this is the user interface. Here you can see the exam assistant. Here we can type the questions or we can give the prompt to the LLM. Here I have written this system or this project is powered by OpenAI's open source model, which is GPT-OSS 20B. 20B because this model has 20 billion parameters. So I have used HuggingFace inference for using this open source model. Here you can see this is the browse files button. So I'll click on this button. Here you can select the textbook or study material which you want. I'll select this one. So after selecting, it will convert this PDF into small chunks so that we can store the chunks into a vector database. So here you can see the message when the chunks are created and stored into the vector database. Here you can see 120 chunks are created successfully, indexed successfully. That means that the entire PDF is now divided into 120 small chunks. Now we can chat with this PDF. So this is the DBMS textbook. So I will ask the question related to DBMS. What is a explain timely key in detail? So here you can see the LLM has given us a structured answer in a structured format. We can also see the what resources were provided to the LLM to answer. So you can see these are the chunks including page number. Here you can see this is the content. I'll ask another question. Explain, let's say ER diagram. Here you can see the explanation related to ER diagram, and these are the sources along with the page number. So next, so the another feature of my project is that it can generate MCQs from the provided PDF. So I'll go here to generate MCQs. So here you can see we can generate MCQs here. You can type the number of how many MCQs you want. And here you can type on what topic you want. So I want the MCQs from DBMS from the provided PDF. So I will type a topic SQL and generate MCQs. So here you can see generating MCQs from your textbook, and MCQs successfully generated 5 MCQs. So this is the question 1, options and the correct answer. Question 2, question 3, options, correct answers, options, correct answers. You can also increase the number of MCQs. Suppose 10 MCQs. Hit generate button, generating from your textbook, and successfully generated. You can see the output is in structured format along with correct answer. So this can be very helpful for studying the during exams which are MCQ based. Here we can see a fun fact. So this was the front end. So this was the front end. Now I will explain the backend code. Now I will explain the backend of this project. So this is the main.py. This includes the fast API backend. This is the core logic of the project, which is written using LangChain. And this is the Streamlit front end. We'll start from here. So these are all the packages and libraries required from LangChain community, like document loaders, text splitters, vector stores, etc. This is the load.env function. We are using this function because I have stored the API key into a .env file. So this function uh, loads the API key. So next, the first function. So this is the load document function. This function loads the PDF file and converts each page into a LangChain document object. Next is split documents function. So why splitting? Because LLMs cannot understand, or we can say LLMs cannot process very large amount of data. I mean, they can process the data, but it requires more computational power and more time. So we split the document into chunks. The chunk size is 100 characters and chunk overlap is 200 to avoid losing the context. Next is create vector store function. Here I convert each text into a vector using a sentence transformer model and store it into a FAISS vector database. Uh, by storing the embeddings into the FAISS database, uh, this help us to allow we can say this help us to use the semantic search. Next function is format retrieved documents. So in this function, what this function does is that it extracts the file name, page number, and the text snippet of the page, uh, and converts it into a structured format so that we can build a clean string for the LLM. It also returns a structured sources for UI. So in UI we can see the page number of the retrieved page number of the chunks. So this is the reason why we can see the page numbers. This function also makes us traceable to know that where are the answers coming from what pages, what part of the PDF. The next function is format chat history. So we provide the entire chat history to the LLM during each query so that it doesn't lose the context. So next main function of the project is building a LangChain. So I have used open source large language model uh, hosted on a HuggingFace. Here you can see HuggingFace endpoint, which is GPT OSS. Task is text generation. This is the prompt which we are giving to the system, giving to the LLM. So this is the prompt which we are providing to the LLM that you have to answer only from the given context. Be pointwise, be structured. Like don't provide irrelevant answers, etc. Here we are providing the context, the question, and the answer, and also the chat history. Not the answer. Here the LLM will provide the answer. Here we are building the rec chain. So this is first chat history, context, question, prompt, then model, then parser. So this is the another function for MCQs. This is similar to this function. Only the prompt is different. That because we are using this to generate the MCQs. So here the prompt is that you have to generate MCQs from and how much number of MCQs you have to generate and all. and that's it. So this project is a complete AI-powered study assistant that can answer questions strictly from the syllabus PDF and also generate the MCQs automatically using the LangChain and LLM. Thank you.
On my way, figured a way out. My pen is a gun, I'm finna spray now. He said I was out, said I was done, look at his face now.